It's my great pleasure to welcome our speaker today, Professor Stephen Michael Lazarus. Comes to us from Florida Tech, the College of Engineering and Science, Department of Ocean Engineering and Marine Science. Also a member of the FIT President's Hurricane Advisory Committee, the American Meteorological Society, the American Geophysical Union, and the University Center for Atmospheric Research, as well as volunteering with the Sea Turtle Preservation Society and Friends of the Archie Carr Refuge. Thank you so much for speaking with us today. Please come up and join us. You can give a warm welcome.
Again, hi Karen, hi Larry. I've been here before. I don't get out much. I tell my students they don't let me out. And by the end of this presentation, you might understand why. In the meantime, just bear with me. So I've been here a few times. It's not the first time we've been here. My husband and I were here many years ago. We were on a panel to talk to you guys about just our lives together in 37 years. But I'm not going to do that today. Talk to you a little bit more about a project, a Department of Energy project that I was funded a couple of years ago. And so I'll walk around and leave my safety of the podium. That picture was just taken, actually, a few weeks ago in Brazil. I took 5 students with me, and we went down there for a technological and cultural exchange in Florianopolis. And we're driving around, and there's a bunch of capybara running around in the city. So that's recent. So I just thought I'd tell you. So anyway, thank you very much for having me here today. And I will tell you a little bit of a story about the grant and what I'm up to and folks that are supporting that grant. So I guess, do we need to launch the presentation? Or? So in the meantime, I can tell some bad dad jokes or something for you guys, right? I got plenty of those. Ask my students. I'll try not to squeeze any in, but I make no promises. It's fine. So you hear they're opening a new restaurant on the moon? Great food, but no atmosphere. I could do these instead, right? That's okay. Okay, so thank you again very much. Yeah, I updated the date. I had the wrong date on there. There's a whole, like any good project, I think there's lots of people involved in this project. And so I have a postdoc who came in from India to work with me on this project, which is awesome. And then colleagues, I'm going to, shameless plug, they're awesome. So I've got email addresses for Dr. Ralston, Dr. Najafi, Dr. Ray I didn't include. The first 2 are much more intimately involved in this project and would be also great speakers for you guys. So, okay, go ahead. Oh, and then little growers. Camille Hadley, really important part of the project, is the community participant, and she's quite the dynamo. And so a big player in making this project work, because if you're trying to make an impact or a change in a community and how we sort of think about solving problems, you have to have more than just academics involved, clearly. So she's a key player. Okay. Paula, how am I doing? Okay? Okay. So this is, I guess we don't have a full screen option on this one, really, because this is, I'm really picky about my presentations, and I've got a lot of beautiful graphics. Can you make it full screen? We don't, I guess that would be great. You should be able, if you have PowerPoint on there, you should be able to hit full screen, or.
Well, it's showing you.
Yeah, and we don't need to see 2 of me, right? One's probably plenty. So if we could do that, that would be awesome, because it looks a little squished. Yeah, I'm patient. If you guys are okay with this, it's nice. I put a lot. So while she's doing that, I can describe you got a little line down the middle of this, and so all the players are on the left-hand side of the project, and so it is a diverse group. Brevard Public Schools are involved, as you'll see shortly, which is kind of fun. And then the National Weather Service is involved locally, the local office. We also have essentially one more, Little Growers is that cartoon on the top line down there on the left-hand side. And that's the group I was just describing locally. Thank you, that is a little bit better. And City of Melbourne also is involved. And then this has been funded by the Department of Energy. On the right-hand side is a complicated diagram with cogs, with little arrows that are rotating around. And this is the center of that, which I'll end the conversation on and not spend much time, is essentially the climate component of the work I am doing. Somehow it didn't get canceled. And so, knock wood, that's a good thing. And the other components basically are I'll talk about today, and that is a sustainability resilience component, the building energy component, and again I guess the other thing is the adaptation component as well, I suppose. I think that's pretty good. We'll go ahead and move past this, but you can see the urban heat island stuff. We can go ahead and hit forward. There you go. So quick outline. It's called Space Coast Rescue. I heard Space Coast earlier today. Usually just when you think about Space Coast, it's kind of Brevard County, right, essentially. So that's sort of synonymous. And then 3 issues I'm going to talk about today. And again, listed there, flooding, heat stress, and building energy, and then I'll just wrap it up. Okay, next. So no presentation is really all worth its money, or there's no popcorn today, so it's just time, people's time. And so, why should you even care? Why are you sitting here? Why am I talking to you about this? And so this risk management, I just don't know about you guys, but my homeowner's insurance is just insane. And if you live beachside, it's more insane. Our energy bills are going up as well, pretty dramatically. So, when things start hitting people's pocketbooks, politics then tend not to matter as much, which probably is a good thing. And then, of course, there are environmental and health impacts. You get extra rainfall, you get more runoff. The runoff goes into the lagoon. I'm not going to talk about those impacts, but clearly, if you're fertilizing and whatnot, your storm drains basically go straight out, and part of the city goes to the lagoon. Some of it goes out to the west into St. John's, but nonetheless, neither are good. And then ultimately, if I want this project to have some meaning, then somehow we have to communicate to our leaders on changes that need to be made, and that's where the urban planning part comes in, right? So, this is kind of important. Okay, go ahead. So I had just some basic questions, really easy to understand, I think. So how do we create, we're working with I'll show you the community here is coming up, where we've really targeted an underserved community just east of Florida Tech. I've been there for 25 years. I had no interaction with that community whatsoever. A lot of people are intimidated even driving through that neighborhood. And I've had nothing but great experiences with the folks, and I'll talk about that today in that area. And so how do you inform the public? Well, you sort of want to give them something they can make. It's information, data. I'll talk about that. So you can't inform without information and data, and I mean correct information, factual information. I feel like silly having to really have to qualify that, that descriptor. But these days, there's plenty of otherwise out there, which is a little bit disconcerting. And then my colleague, Dr. Najafi, who I highly recommend, can talk to you guys about building energy. He's a substantial component of this project. It is Department of Energy, right? So it's got to have some sort of that kind of aspect to it. And then how do we help folks plan for the future, right? What's coming down the pipe? So, okay, next. So that's the community. So Florida, the sort of the Space Coast in the center, and the Space Coast basically to Florida Tech, Stone Middle School showing up there. Those 2 polygons, or we call them polygons if you're in the GIS world. They're just these irregularly shaped features on the map there. And what are you looking at? Basically, you see the Indian River Lagoon, and so folks know those neighborhoods. And then you can see the Melbourne Causeway up there, a little nick of that feature. And those polygons were actually, we pulled those when we wrote the proposal. They came out of FEMA. So the Federal Emergency Management Agency, they are identified as communities of climate challenged communities. And when you think about that, they're just basically a socioeconomic issue mostly. And so I'll talk a little bit more about that as well. Next. I like this. I'm a shopper. I'm a foodie. I don't know how many people like to cook and eat at home. I like to bring this really into it. So I love reading my labels. I read what I eat. I'm a vegetarian mostly, and I love it. Where do you get your protein? I just want to run around with a shirt. Where do you get your protein? Because I watch people put stuff in their mouths that horrify me. So I don't know why they're worried about where Dr. L gets his protein. I'm on my little soapbox here. But I will say this, you turn a can around, right, and you want the ingredients listed so you can make a decision. If you educate yourself, about something, you have the data, you have the information, all you have to do is turn the label around, and sometimes it'll say in generic ingredients, which kind of irritates me. There might be something in there you don't like. But reporting that information is important so you can make informed decisions. Without the data, turning the can around doesn't mean anything, right? And so this is my analog to moving forward in the discussion today with you guys. I think this is important, right? So at least you have the choice to do it if the information is there. Okay, next. So cartoons in the AI world look like this. And so AI has gotten pretty powerful. I'm using it quite a bit. So it generated this diagram. So community weather stations. How do you get data, right, into communities that are looking at climate resilience issues? Well, I'm a meteorologist or an atmospheric scientist, so what do I want to do? I want to collect more data. When we were planning this proposal, you can go, I'll show you, you can go to Weather Underground, you can go to CoCoRa's Rain Gauge Network, and you start zooming in on the maps, right? And all of a sudden you see these data void regions where no data are coming in. And you know what? They seem to be inextricably linked to poor communities, white or black. All right. And so I'm like, well, that's interesting. Probably not a good thing if you're trying to make change, because if you're trying to go to people to convince them that, hey, we need better infrastructure, then you need data to sort of back that up. These are the arguments you want to make to your community leaders. So we actually, I'll talk to you about the community weather stations here shortly. Then we're looking at things like rainfall, temperature. You can always go to the National Weather Service in Melbourne and get the data from there. But how representative is the data at the airport to these communities, right? The communities have different, in some sense, some kind of different impact on heat. They have, and it may not be representative, different rainfall and things like that. So, I'm going to talk to you about the urban heat island effects, a little bit about flooding, not much about building energy, because I'm going to leave that to a follow-up for you guys. But I will talk a little bit about the work being done there. And then, the bottom of this tree is the sustainability part that kind of links all this together. And so you can't really read that there, but we're talking about public health. I can barely read it. Shrinking your footprint, your environmental footprint, if you're in, and that kind of stuff. Supporting, basically, as we move forward, resilient development, maybe thoughtful development, right? Because rainfall increases, but we're also building basically unmitigated building. Where's the water going, right? It runs off and the neighborhoods flood. I can show you a picture of my neighborhood after Irma. I'll show you that. And then lower energy bills. That's the building energy component. And again, the we're good. Go ahead. All right, so I love it. So if you're a weather geek or just a data geek, a wonderful world basically of citizen science. So the Weather Underground, that's a map of, you can see the Cape Kennedy on the left, basically. All those stations are people, like you, me. I have one in my backyard, a couple $100. Go on, get your data, go on, put yourself on the map, basically. We get data streaming. The Weather Service basically has there's only a couple of ASOS stations. So these other data locations are really useful. There's a lot of them. Without them, that map would be empty except for a couple basically governmental locations that have and collect weather data. And so when I was zooming in on this, I could start picking out the neighborhoods that weren't doing so well. And then on the right is what they call CoCoRa's, and those are just rain gauge only. And so I'll talk about the rain gauge measurements as well. If you're interested in flooding, you got to be measuring rainfall, right? And so you can do this electronically and automatically. Some of those aren't so great. There's no substitute for the old-fashioned. Hang a rain gauge basically on there and train the citizen science on how to make those measurements and report daily amounts of rainfall, which are important to the project. Okay, next. Oh, actually, and you can see us working. Go back one real quickly there. Can you go back? So, and of course, the middle pictures are some of the folks we worked with in the neighborhood in the last year to get the stations up and running. Okay, thanks. Go ahead. Not much else here. Let's go ahead past this one. Skip. Okay, so flooding. I don't know if you guys, I don't know how many folks have neighborhood flooding issues. I like to have this discussion. So if you get a lot of rainfall, any issues? So I know my neighborhood goes under. And so it's like how about from a hurricane like Irma or anybody around for Tropical Storm Faye? 20-something inches of rain. You got flooding from that, right? So, so from the science standpoint, without getting geeky on you, you heat the planet, right? You heat the water. Water evaporates, and it evaporates more rapidly, basically, into the atmosphere if it's warmer. And so if you have more water vapor in the atmosphere, right, then you have more, when you get condensation, you have more rainfall. And there's evidence, clear evidence, that especially the big systems like tropical cyclones and hurricanes and other things we call like mesoscale convective systems are getting wetter. Okay, and so flooding becomes more problematic, and neighborhood flooding is an issue. When we started to write this project, I noticed, anybody ever go to the FEMA, they have web pages with flood information, but it's all along things like Crane Creek and coastal flooding. They don't go into neighborhoods. And I get why they don't, because it's highly political, right? You start showing areas that are prone to flooding in a neighborhood scale, which is what we're doing here. You have to be careful, right? Because you could have the opposite effect you desire. Like, for example, if an insurance company gets a hold of the information, what are they going to do with it? It's almost like your health information, right? And so it's crazy. So neighborhood flooding, big issue. And so you see the top line, the causes. There's sea level rise issues, right? There are what we call storm surge on top of the sea level. So those are basically hurricane winds driving basically the coastal ocean into inland. And then there's intense rainfall, and the intense rainfall one's not covered much in the scientific literature. It's not all that well understood. And then, of course, there are strategies, obviously, how you inform the city and state and county folks on how to improve things. And there's green approaches to basically improving things. I'll talk a little bit about that. There's zoning regulations, clearly. Everybody's familiar with those. And then, of course, warning people, right? That's important. Yeah. Okay, go ahead. Next. We'll see how this works. Okay, so the model we were running is what we call a compound model, and so it covers all three of those areas. Surge, it covers basically rainfall, we call pluvial, fluvial, fancy words for what it covers, and so the idea, this little figure cartoon here, you can see sort of tides coming in. If you have a hurricane making landfall during high tides and the peak of the storm, not a great scenario for storm surge coastally. And then basically, so that's the wind-driven component. And then, of course, you have essentially rainfall, Crane Creek, Turkey Creek, right? They can flood along the banks of those two creeks. And so that drains in, and then you have this region in between where you have both. And so you have compounding factors on flood, and this is happening in a lot of coastal areas. And then actually, forget all the storm stuff, we have what we call the nuisance flooding or clear weather flooding that's becoming really problematic along the east coast of the United States. Without any wind and surge, it's just basically sea levels coming up, right? And so you get these abnormally high tides about twice a year, both spring and fall, and those are producing flooding in the coastal zones in beautiful weather, right? So these are all issues. Go ahead, so next. So what are we doing? So that's my neighborhood. That is my neighborhood. So after Irma, yeah, so that was 12 inches of rainfall, just to let you know, some neighborhoods. And as you continue to build, the water's got to go somewhere, right? So this is not just climate, right? This is just us invading the environment, right, and changing our environment, basically. And we call them impervious surfaces, right? So this stuff's not soaking into what was once grass area. I don't know if anybody's watched the destruction of, I call it, I'm not an Ent, but I am a Lord of the Ring Tolkien fan. So they clear cut basically off of Florida Avenue, just south of the community I'm working with, and across from what was Andretti. It was now that's gone, and it's a huge swath, and they cleared it, and by Florida standards, not only did they clear all that debris and all that foliage, they burned it all in place, and they've been burning it for 6 months, and we've been catching, I lived right downwind of that, so we've been catching a lot of that particulate matter from that, so it's pretty amazing. So anyway, see those little red dots on that map? So those are the two polygons. There's Melbourne Causeway at the upper portion of the diagram, Crane Creek showing up there, and the top red colored polygon. All those little dots are weather stations. We put weather stations, 11 of them in, one's at Stone Middle, okay? So we put a bunch of them in, none existed before, and they've been collecting data. It's available on Weather Underground. You can zoom on in, click on the map, and every 5 minutes, you've got data. And we're using this data to do science, which is really awesome. Okay? Oh, sorry, I'm not talking into this enough, maybe. Okay, go ahead. All right, more cartoons. And so what's going on in the heat stress? So you think, okay, so now you get all this data, right? Rain gauge data, precipitation. So we have something to basically take the folks saying, hey, we've got, and people taking photographs and pictures of the flooding, right? And this, you know, my neighborhood floods, but some don't flood at an inch or two of rain. Some need more than that, right? But you need this sort of documentation. But you also are measuring temperature. So my building energy eye, right, the guy, Dr. Najafi, who's working on this component, basically, is using the temperature data, okay, to help basically get a better idea of building energy efficiency, okay, and developing some cool models with that data that we're collecting. Normally, he would just go to the Weather Service in Melbourne and pull the data basically from that site. They call it typical meteorological year data. It's kind of developed from these, but they may not be representative of the neighborhood. Right? So these stations are very helpful. And then we're using the data. Temperature and relative humidity is all you need to get heat stress. So they calculate something called a heat index, and that is just temperature and relative humidity. Anybody going to argue about that one? Sometimes 90 degrees can feel okay if it's dry out, right? Not so much in Florida, but it does in some places. So, so we're using that data basically, and we're running models to see how well we do in terms of predicting the heat index and heat stress from output temperature and relative humidity if you have a bunch of data. And so that's important. I'm going to not spill the beans, but I have a last slide that kind of takes you back out 360 to see where all this is heading. So we have a lot of current data, but what about the future? Just dropping that right here for you guys to think about. I'll get to that. I promise I'll wrap that up. Go ahead, next. So just some model output. From some heat stress. So this is sort of the science geeky part. We're running a weather model, and we're putting in basically information and then running it for these days we've identified in the recent past. And we're looking at, the Weather Service has something called cooling degree days. They're miserable days in Florida in the middle of the summer, for a lack of a better description. No one knows about those, right? And so we're running simulations for those days, and that figure that's a little scrunched on the heat stress side of that diagram, it shows a red line and a blue line, upper left figure, is the model versus the airport data. So the model does really well. And this is really important from a science perspective. There's a lot of skepticism out there about science these days, but we're very rigorous about testing our models on known data first before we tell you anything about the future. If your model doesn't work with known data, then why bother, right? So, but if it does, it doesn't make it definitive that you've got it right in the future, but you feel a little warmer and a little fuzzier of the way the model's built, the model physics and whatnot. Really important. So a lot goes into this. Next. Okay, so a little shameless plug. There's his email, by the way, just in case you wanted to know. This guy's awesome and gives great talks on building energy efficiency. And just a sort of a little summary there on the right-hand side on these days in the summer that have high cooling demand. We all know about the cost of our electric bills have gone up quite a bit over the last, I'd say, half a dozen years or so. And the idea is, as we move forward, we need affordable solutions on trying to basically accommodate to a warmer and more moist and more uncomfortable climate here in Florida. And so these are important things. As a researcher, I have to say, I have to take a second out. In all honesty, we're trying to make a difference. I mean, I'm getting up there in my career. I have a few more, I got involved in this project because I really wanted to go out feeling like I've made an actual difference with communities and working with people. So I have to say this one's a challenge, right? When you don't have a lot of money, right? What do I think you have a couple of routes to go, right? You go through the city, right? And say, hey, we need infrastructure. We need cooling centers. We need certain things, basically, to make things just to to sort of reinforce things as we move into a warmer future and a wetter future. I think that's a doable thing. And then, so that's, I think, an important thing. But I have to say, after 2 years into the project, I'm not so sure that, and then of course, just that sort of community focus on taking this information and making these requests from your sort of politicians that represent you are really important. So just a couple of comments there. Go ahead. It's tough. So this is one of his figures. The little pie diagram shows about 30% of your electric bill is air conditioning, your power, your energy use. And the big slice is appliances and electronics, just in case you didn't know, right? Certainly cooling is a big issue, and that's the main one here as far as the energy consumption, as far as the stuff I think we can do. Oh yeah, the other thing, of course, is one doable thing for communities is planting trees and putting in more vegetation and more natural environment and less basically hard surface that mostly keeps the temperatures up at night. Right? You ever get near a road or something at night, or even the walls of your house that are exposed to the west walls that radiate basically into the evenings in the summer. So basically those are, I think, more affordable solutions, right? We're working with a poor community, you know, it's like they can't afford some of this stuff, right? So this is a struggle that I go through. Go ahead, next up. So we're doing assessments in the community. So we've got all these stations. They're at people's houses. And so we're getting ready this week with their summer camp to go house to house. Now we have all this data and sit down with them and look at their Florida power and light bills with them. And those are going to get used for residential energy assessments. Okay. And then Stone Middle, we just completed that energy assessment. We've been working with the officials at Stone Middle to do that. And so this is some of the work my colleague, Dr. Najafi, is doing. And again, on the right side of the diagram, he's got an energy analysis and the building energy model. He's developing building energy models for these residences to get an idea. Because once you build a model, right, then you can put data in that's not observed data. You test it on the observed data. But then you can actually look at, okay, what's it going to look 10 years, 20 years from now, basically, if our temperatures change and warm and our relative humidity goes up, these things are important, right? So that's sort of the future weather data part of the figure. Okay, next. And then drought-tolerant landscapes. My colleague, Dr. Emily Ralston, is kind of led this effort at Stone Middle. My yard is mostly native. I don't water it. My neighbors don't believe me because it's beautiful. I have a swell. I'm so proud of this. I'll show you if you guys want to see some pictures. I have a swell just full of mimosa, and the petunia, the purple petunia flowers are all native. Not a drop of water. In fact, less water the better because I get no weeds. It's easier to take care of, and they're highly drought tolerant. And so these things are things that can actually mitigate flood damage to your house. If you have buffers of plants that are native, it limits water use, so it shrinks your footprint for water. Like I said, I don't water, and my yard's the prettiest one in the neighborhood. And so I brag about it. I have proof. It's on my phone. Come talk to me. So that's my shameless pitch. And all right, so next. And so we've been working with Stone now for the last year. You can flip on through. And then there it is. That's the group. We had 30 people out there, and we went to the Florida. What's the native? It's the nursery's just down, not too far from here, right? Just a little bit east of you. They're a great native nursery there. I forget their name. We went to them basically, and they helped us design the gardens there. So that's us after putting them in. This is at Stone. What's that? It used to be Maple Street. They're gone, but there's another folks that. Anybody? Native butterfly. Thank you. I'm getting old. Sorry. Next. Look at it now. It's starting to be. And so it was like just a few months into the project, things were growing, and we had butterflies everywhere. You know. Yeah. I don't use any pesticide. My neighbors put enough pesticides down and enough stuff to keep their St. Augustine grass green to choke a horse. So nothing. And our yard is full. I saw tiger butterflies this morning. It's just great. Yeah, it's just pretty amazing. If you build it, they will come, as they say. And so, if you like butterflies, let your yard die and put something in that's more sustainable. That's all. So I call it the microbiome. I don't mean the one in your gut. This is basically just a bunch of stuff flying around. So go ahead, next, yeah. Oh, look at it now. That's part of it on the right. Isn't that beautiful? So here's another shameless plug. Anybody who wants to get out with us and help us do some weeding, I'll take the help, right? We've been doing it. So we had, this last semester, getting people out to actually pull weeds can be a challenge. We all know that in our own yards. But hey, if you want to help, let me know. A couple hours on a Saturday once a month would be really appreciative. Okay, next. So I'm going to wrap it up here. I just gave you a whirlwind, excuse the pun, overview, basically, of what we're up to. So, okay, so you have all this data collection for flooding. We are running models for, I didn't see my flood model run. We were running flood models in the neighborhood. For some reason, we may have skipped over that. I don't know what happened to that PowerPoint slide. Nonetheless, doesn't matter. We're running basically atmospheric models to understand, basically see how well we match the observations that we're collecting, the new data we're collecting. So where does it all go, right? So we're working with Argonne, and they have a lot of compute power, and they have been running climate models for years, and they've shared their climate model output with us. So we're in the middle. That's a picture of, anybody recognize that high out in the middle of the Atlantic Ocean that you hear about it during hurricane season? It's that subtropical high, right? That steer hurricanes, that air around that rotates around those lines in a clockwise manner. So all that south side of the south central Atlantic is all that easterly flow that we get in the summertime. In fact, we had a couple of weeks of very brisk easterly onshore flow, dry and windy, if you hadn't noticed. That is abruptly ended, basically, because that position of that high has shifted southward. And you see that little red line that runs through that feature. One of my graduate students has basically taken the data and identified the center of that feature and run it, basically a line through it. And depending where that line is and how it intersects the Florida coast, determines whether you have onshore flow. If you have onshore flow, then that pushes all the weather to the west coast of Florida. If you have offshore flow, it pushes it all to our coast. So that red axis has shifted recently south, and we've started to get westerly flow from basically land to water. So the thunderstorms that develop inland don't move away from us, they move toward us. We should have an activity event today. So I'm kind of wondering what that's going to be like in 10 or 20 or 30 years as things continue to warm, okay? And because it matters if you want your yard watered, right? And you can't just keep pulling groundwater up and turning your sprinklers on. That's no miracle, right? You have to recharge the water that's under there that you're pulling out of the ground. It doesn't just come from heaven. And so basically, so where are we heading? So we're looking at so when folks do this work, this is my kind of wrap-up slide. So here's where we're heading. So we have folks that have historic data. So this is basically July 2010, all right? And then there's a precip map next to it in green and yellow. The yellow is light precip over a good chunk for that month, that year in Florida. And it's because that ridge axis we had on the East Coast, right? I have that box on the East Coast for a reason. It's super dry. We sometimes, even in the middle of summer, have weeks of dry weather where your large yard, if you don't have water, dries up, right? And this is an issue, right? We live here. If it doesn't, we don't have that summer convective thunderstorm cycle like we're used to all these years, and we have this population growth, the stressors of population growth going on. This is what's going on out west in the reservoirs, you hear about Lake Powell, right, and whatnot, those big reservoirs drying up. I've seen even our little lake in our neighborhood's gone down to like nothing, right, after the last month and a half of pretty dry weather. Will it recharge? That's kind of like a microcosm of our climate, right? So we have the historic data. My point is we have the historic data. We want to see how well we do with the historic first, and then we're going to take the same model output that goes 10, 20, 30, 40 years into the future, plug it into our models to see basically whether or not what the flood risks are and the change in the heat risks, the heat stress in the environment. And this is all pretty local here in Florida. So that's sort of the big picture. So anyway, I probably should have led with this. I always, after teaching for 25 years, do you bury the lead or do you lead with it? I don't know. So hopefully I didn't. I think that's where we're heading. That's what we're doing. Thank you. Yeah. And we got a couple of papers we submitted. Big deal.